Welcome to the Deep Dive. We're here to break down complex crypto projects and tech into insights you can actually use. Today, we're looking deep into the infrastructure of Web3, specifically the graph, also known as GRT.
Yeah, it's a really foundational piece, often called the decentralized Google. And we've got a lot to unpack: reports on its tokenomics, its architecture, adoption numbers, but also, crucially, some potential economic issues we need to talk about.
Right. So our mission today is to get past the buzzwords. What does the graph actually do? Why do massive protocols like Uniswap and Avi apparently depend on it? And, does this whole thing have a sustainable model once the initial hype or subsidies fade?
Exactly. We need to figure out how this decentralized search engine really functions under the hood and what its biggest hurdles might be long term. Let's maybe start with the core problem the graph was built to solve.
Okay, let's unpack this. So why is it so hard just to get data out of a blockchain? Aren't they just databases?
Well, yes and no. Their database is optimized really entirely for security and making sure data never changes, not for retrieving it quickly. Think about Ethereum or Solana. They're essentially just these really long, secure logs of transactions. Now imagine you're a developer building, say, a DeFi dashboard. You need aggregated data, like historical trading volume, for a specific token pair on Uniswap. That information is scattered across maybe thousands of blocks. It's hidden inside complex smart contract events. It's just not easy to grab.
So it's not like a normal database where you can just query what you want. The data's there, but it's messy and hard to access for applications.
Precisely. The sources we looked at call it information chaos. Traditionally, developers had to build these custom, often clunky systems themselves. They'd have to manually process events, parse metadata, pull data from all these different blocks. It makes building apps slow, expensive, and really difficult to scale up.
Okay, so it sounds like trying to read, a massive, unorganized library every time you just need one specific fact.
That's a pretty good analogy, actually. Yeah. If the raw data is chaos, the graph aims to be the librarian or maybe the index.
The Google for blockchains analogy makes sense. How does it create that order?
Right. So just like early Google indexed the messy web, the graph indexes messy blockchain data. It pulls the information, processes it, structures it, and then stores it so it's easy to search.
And is it just for Ethereum or?
Oh, no. It's much broader now. It organizes data from I think the latest number is 90 different blockchains. We're talking the big ones like Ethereum, Solana, but also layer 2s like Arbitrum, Polygon, lots of them. And it standardizes this data into open APIs. That's where the term subgraphs comes in.
Subgraphs. Okay, so those are like the specific index files for particular data sets.
Exactly. They're like predefined recipes. A developer doesn't need to sift through raw blocks. They just find the right subgraph and query that for the structured data they need. Much simpler.
That definitely clarifies the why. So let's get into the how. It's decentralized, so there must be different actors involved, economic incentives. Can you walk me through the main roles?
Absolutely. It operates like a decentralized marketplace, and the GRT token is what fuels it. There are basically four key players. First, you have the consumers. These are the dApps, the developers, the analytics platforms, anyone who needs the index data. They pay query fees in GRT.
Okay, the customer's paying for the service. Got it.
Second, you have the subgraphs themselves. As we said, they're the definitions, the instructions for what data to pull and how to structure it. Third, the indexers. These are the real workhorses. They run the specialized software, the graph node, to actually perform the indexing work and serve the queries. And crucially, to be an indexer, you have to stake GRT. Quite a bit, actually a minimum of 100,000 GRT. It's like a security deposit.
Whoa, hang on. 100,000 GRT, that's a significant amount of money.
It is, and that's intentional. It provides economic security. Well, if an indexer provides bad or incorrect data, their staked GRT can be slashed. They risk losing it. So there's a strong financial incentive to be honest and accurate.
Okay, slashing makes sense for security. But 100,000 GRT, doesn't that immediately create a huge barrier? Like, only wealthy players can afford to be indexers. That sounds kind of centralized.
That is the core tension. You're right. It's a major point we'll need to revisit when we discuss the risks. High stake for security, but it potentially limits decentralization. It's trade-off.
Okay, so consumers pay, subgraphs define, indexers work and stake. Who's the fourth role?
The curators. Think of them as scouts, or maybe quality control. They use their own GRT to signal on subgraphs they think are high quality and likely to be in demand. They essentially help guide the indexers, pointing them towards the most valuable data to index. And in return for their curation, they earn a slice of the query fees generated by those subgraphs.
Interesting. So curators bet on which data sources will be popular.
Pretty much. And when a consumer actually queries the data, they use something called GraphQL. It's a query language that lets them ask for only the specific data points they need, nothing more. Makes it very efficient.
So it's a whole ecosystem, staking, slashing, curating, all designed to ensure the data is reliable and delivered fast. What's the payoff? What are the actual results?
Well, the performance claims are pretty staggering. They introduced a technology called substreams recently.
Substreams. Right, what does that do?
Instead of indexing data block by block, sequentially, which can be slow, substreams allows for massively parallel processing. Data can be processed and streamed almost in real time.
Parallel processing, that's always the key for big data tasks. Does it make a real difference?
Apparently, yes. One report cited a specific case with an analytics firm, Amber Data. Substreams reportedly sped up their indexing by, wait for it, up to 72,000%.
72,000%. Okay, that's not just an improvement, that's a different category entirely.
Exactly. It enables things that just weren't feasible before on decentralized tech, like real-time trading dashboards or super responsive dApps.
And are people actually using this? What does the adoption look like?
The adoption numbers are, frankly, huge. The protocol supports over 75,000 projects. That's a massive network effect right there. And get this, it's processed over 1.27 trillion queries since inception.
1.27 trillion, that's astronomical.
It really is. It puts into perspective how much activity is happening. And these aren't just small projects. We're talking core Web3 infrastructure.
Yeah.
Uniswap, Aave, Decentraland. Many big names rely on the graph for their user-facing applications.
So it's become deeply embedded. And what about traditional finance or institutional players? Are they involved?
They are, which adds another layer of validation. The Graph Foundation raised a $50 million Series B round led by Tiger Global Management, a major institutional investor. Coinbase Ventures is also a backer. And maybe even more significantly, Grayscale included GRT in its decentralized AI fund. As of July 2025, it had an 8.5% weighting. Yeah. So Sirius Capital sees it as key infrastructure, potentially for AI too.
Okay, impressive tech, massive adoption, institutional backing. It sounds almost too good to be true. Let's pivot to the critical side. What are the risks, the potential downsides?
Right, this definitely raises an important question. Is the current model sustainable in the long run? Because the biggest vulnerability highlighted in the research is really around the indexer economics.
Okay, tell me about that. You mentioned the 99.1 problem.
Yes. So the network currently relies heavily on GRT token inflation, new tokens being created, around 3% annually to reward indexers for their work. The alarming stat is this. Right now, roughly 99% of the income indexers receive comes from these inflation rewards. Only 1% comes from actual query fees paid by the consumers, the real users of the data.
Wow, 99% subsidy. That feels unsustainable. Like the training wheels are still very much on.
It's a major concern. For long-term health, that ratio needs to flip dramatically. The network needs to generate enough real demand, enough query fees to pay its indexers without relying so much on inflation. If it doesn't, the constant creation of new tokens could eventually put downward pressure on the GRT price, undermining the whole economic security model.
And let's circle back to that huge staking requirement, the 100,000 GRT. You mentioned centralization risk earlier. How serious is that?
Well, it seems quite real.
Yeah.
Because the barrier is so high, the number of active indexers is relatively small. One report noted only 71 active indexer nodes in the first quarter of 2025.
71. For a network serving 75,000 projects and trillions of queries, that does sound concentrated.
It does. And with a small number of powerful indexers, you start worrying about risks like collusion. Maybe they coordinate to keep query prices high, or censorship. Maybe they collectively decide not to index certain types of data.
Which goes against the whole point of decentralized, permissionless infrastructure, right?
Exactly. It undermines the core value proposition. So balancing security with decentralization remains a critical challenge.
Any other major risks?
There's always the lingering regulatory risk. Like many utility tokens, especially those involving staking and rewards, there's uncertainty about whether regulators like the SEC in the US might eventually classify GRT as a security. That hangs over many projects in the space.
Okay, that makes sense. So bringing it all together, if you had to summarize the graph in just a sentence or two, balancing the good and the bad, what's the takeaway?
I'd say the graph is undeniably a critical piece of Web3 infrastructure, like a decentralized data layer, already used by thousands of apps across, 90-plus blockchains. It's highly adopted and technologically advanced. However, its long-term success really hinges on two big things. First, shifting its economy from being mostly subsidy-driven to being fueled by real user demand for queries. And second, managing to maintain genuine decentralization among its crucial indexer network despite high entry barriers.
A powerful tool facing significant sustainability and decentralization challenges.
Got it. And looking ahead, what's the big vision? Where does the graph go from here?
The vision is ambitious. They talk about creating an interconnected graph of data, essentially a global, unified, verifiable knowledge graph built from all indexed blockchain data. And a key part of that is integrating with AI. They're planning something called the Graph Assistant.
A graph assistant, what would that do?
The idea is to allow large language models, AI like ChatGPT, to query the graph's verified data using just natural language.
Wow. So you could just ask an AI, show me the verified transaction history for this NFT across all chains, and it could potentially pull that directly from the graph.
That seems to be the direction. Imagine if AI agents could reliably access and act upon verified real-time data from dozens of blockchains instantly.
What kinds of completely new applications or analyses would that unlock?
Oh, yeah.
That's a pretty big thought to end on. This is a great point to quickly pause and remind our listeners of something. That's right. If you're enjoying how we break down these complex projects into simple pieces and want more reviews just like this, make sure you subscribe to our channel, CryptoBox. We do all the complex research so you don't have to.
Absolutely. Thank you for joining us for this deep dive into the graph. We'll catch you on the next one.